So hello and welcome to the ongoing AS and A-Level Java series, and in this episode we are going to be looking at OOP. So what is OOP? OOP is an abbreviation for object-oriented programming, and basically OOP is a programming paradigm or a programming approach we used to develop software, as it were. So we have two main paradigms that we make use of. You can go with the procedural approach, whereby you write your code from the top down and you have your full program. And then of course you can also talk of the object-oriented approach. So what is the difference between the two? So with procedural programming, you're writing your procedures or methods that perform operations on the data, right? Whilst with object-oriented programming, what you're now doing is you're actually creating objects, and within the objects you are encapsulating the data and the methods, as it were. So why should you want to choose object-oriented programming? Well, because remember we said that you are actually creating objects, right? And each particular object you're going to give it its particular data and as well as its particular method, so that it can act however it desires on that particular data. So using this approach, you'd realize that object-oriented programming is quite faster, and it's much easier to execute object-oriented programming, rather object-oriented programs rather than procedural programs, because the procedural programs are actually going to have all of your code in one place or in one file, as it were. So we are talking about maybe tens of thousands of lines of code if you are doing a mission-critical application or if you are doing a mission-critical program. But with object-oriented programming, you can have the same amount of lines of code, but you realize that now that these lines of code, they are going to be spread across several files. So maybe you're looking at most one file might actually have say 50 lines of code, is it? So it's actually quite easier to work with object-oriented programming languages than to work with procedural languages. Then it also provides a clear structure for the programs. Again, just refer back to the example that we talked about just now, that you are looking at several thousands of lines of code, and you now organize those lines of code into several files. So it's much easier to identify or to pinpoint a bug, as it were. Then OOP also helps to keep the Java code dry. So in software engineering or in computer science, we talk about a concept called DRY, which basically is an acronym for don't repeat yourself. So whenever you write code, if you want a certain segment of code, or rather if you see that a certain segment of code is actually going to be useful in several use cases, as it were, you should actually wrap around that code in a procedure or in a method, as it were, as we call them in Java, so that it becomes easier for you to reuse that particular segment of code wherever you want to use it. So you'd realize that now with procedural programming, whilst you might do this, it might actually be a bit difficult because you have all your code in typically maybe one file, right? But with object-oriented programming now, DRY is actually quite easy to implement, because you can just create an object that contains this certain segment of code that you would want to keep on using as you develop your application. So you realize that it's quite easy to maintain, modify, or debug programs that are written using the object-oriented programming paradigm. Then it also makes it easy to create fully reusable applications, right, with less code and shorter development time. This is I think this is the main benefit of object-oriented programming. Was take, for instance, the C# programming language, which is used by Microsoft, right? The C# it inherits from, or rather it is an extension, or rather it was built based upon Java, right? So the whole idea of C# is to create Windows form applications like the one that you see right here. Like I have Microsoft Office PowerPoint, right? So you're saying now that you can create objects, like for instance this menu right here, it can actually be an object, right? These menu items can actually be objects. So it's much easier to create knowing that you are focusing on this particular object, and this particular object is going to have its own behaviors and actions that it can perform upon clicking, upon hovering over it. Like for instance, if I hover over here, you realize that I get a tooltip, right? It's telling me that this is the paste. If I hover over here, I get that tooltip. So this is quite much this is much easy to implement using object-oriented programming, because you're creating objects, then you can now glue those objects together by methods, right? So each particular method, or rather each particular object, is going to have a set of methods that define how it behaves in a certain situation, as it were. So those are just some of the benefits of doing the object-oriented approach for developing programs or software, as it were. Then we might have mentioned objects, right? So what are objects? So we can't really talk about the discussion of objects is not complete without talking about classes, right? Because classes and objects, whilst they are the fundamental building blocks of object-oriented programming, you realize that you cannot create an object without a class. So here I have a diagram going on. I have a class on the left, then I have an object on the right. So you might think of fruit as a class, right? And apple, banana, mango, right? Those are now the actual objects, right? So I want you to see how a fruit defines objects, and how each particular object can be different from the other objects that belong to the same class. So that's the whole essence of object-oriented programming. Let's look at another example. Here we have the class of car, right? And we know that cars, whether you have a Volvo, you have an Audi, you have a Toyota, right? Basically, you can do pretty much the same thing. You can drive it, you can carry stuff with it, and so forth and so on, right? But you'd realize that now a Volvo has additional functionality that may not be available in an Audi, or that may not be available in a Toyota. So basically, car is the class, and objects, the Volvos, the Audis, the Toyotas, are going to be your objects. So having looked at this example right here, or these diagrams, we can then actually come up with a working definition for a class. So a class is a template for objects, right? Or it's a blueprint for creating objects, and an object is an instance of a class. So by instance, we mean that it is the actual implementation of a class. So a class generally, if I were to talk, if I just say think of a car, right? You can just think of something that is maybe say 4 wheels and so forth and so on. But now when I say think of a Toyota, you can actually think of a certain type of Toyota. Maybe talk about a Toyota Hilux and so forth and so on. So we are now saying that now is an actual instance of a car, as it were. So when the individual objects are created, they inherit all the variables and methods from the class. So I think maybe we'll be looking at this in the next episode. But basically, you define your blueprint, right? You can say that I want my car to have 4 wheels, I want my car to have a color, and so forth and so on. Then when you actually create the instance of that particular class, right, which is an object, you can then assign the different types of colors to a specific object. You can even give a different type of functionality, and so forth and so on. Alright, so I think that's just about it for this episode. I'll see you in the next one.